Hey, what's up guys? My name is Cherno. Welcome back to my game engine series. So I just got off a plane like yesterday and I'm super jet lagged. I've been in Europe for like the last 5.5 weeks. So this video is kind of going to be a little bit all over the place. Forgive me, but I'm very tired. Anyway, welcome back to my game engine series. Last time we talked about transforms, check out that video if you haven't already. And today I'm going to talk to you about materials. We're going to have a bit of an introduction to materials, why they exist, how we're going to use them, why we need them in game engines. I'm not going to make an in-depth video with like diagrams or anything. I'm going to save that and just have that be about materials and whatever in the future. I promise you guys that. I know that I've said there's going to be a bunch of in-depth videos. If anyone has a collection of the in-depth videos I promised to make, please post it in the comments, by the way, because I'm going to start working on them like next week or so. But we're just going to have a bit of a basic overview of what materials are. We're going to quickly jam in a very basic material system. Not really even a material system, but just to kind of give you the idea of how everything ties together practically. And that's going to be kind of it for today. And then I think next time we might continue on with shaders or textures, because textures are also something that I want to get done. But anyway, let's talk about materials. Like, why do we need a material system? So right now, let me just maybe launch our code and we'll see what we actually have. Okay, so we had this triangle and we were able to like rotate it and move it around, and we basically could move the camera around, I guess. And then we had like a bunch of tiles that we were rendering as separate objects with separate transforms, is what we did last episode. So suppose that we wanted to make one of those triangles like, I don't know, or like one of those squares. As we kind of decide to draw each square, we want to make them a different color. So how does that work exactly? Well, so far we know that shaders exist as a way to essentially tell our GPU what to do with data that it gets, how we actually realize, I guess, that data onto our screen, right? So we have vertex positions, we have, our screen kind of coordinates or whatever. We need to draw certain geometry. We've given a draw command, a draw call, to actually draw like, say, 2 triangles to make up like a square, right? We've got all that data, but how do we actually draw it? Where do we put on the screen? Vertex shader takes care of that. And then how do we shade those pixels? Those pixels, what color do they amount to? The fragment shader or the pixel shader deals with that. So that's what a shader is. It's a program which determines all that. And if you're kind of rusty on that, check out either my OpenGL series on shaders or the actual shaders, I think, video in this series, because that was quite informative as well. That's what a shader does, right? So that's great. And we know that what you should be able to do right now is, if I say make the triangle red, you should be able to go into the shader and actually change the code and just make it output a flat red color. Easy, right? Because outputting blue, I'll change some numbers around. Suddenly this shader is going to output red. And I think we even called this the blue shader. But in the real world, we like to write shaders that are a lot more flexible than that. You don't want to just write a shader that's like your blue shader and that's done. The reason is that shaders it's like a program, right? You wouldn't write a program which just calculates a single number. It would be much better to write a program which takes in 2 inputs and then like adds them together or whatever, and then gives you your answer. Isn't that much more kind of useful? You could have a program which computes 10 plus 5, right? And that's it, that's your program. Great, it can compute 10 plus 5, it's amazing. But what if I make a program which asks the user for 2 numbers and then adds them together? How much more powerful, how much more useful does that actually become? Same deal with shaders, right? We could write a shader that just outputs red. Totally fine, we could call it the red shader. Great, we've got a blue shader, why not have a red shader? But what if I could make a shader that takes in some data as an input and then outputs that color? And I could call that shader the flat color shader, right? And all it would do is take in an input, which might be red, might be blue, might be any color I can think of, and then shades all the pixels to that color, right? That would be a lot more useful, wouldn't it? And that's kind of where a material comes in. Because what we do is we write our shaders as flexible as possible, right? It might be written by like, an engineer or a technical artist or something like that. And then all the other artists who are working on the game, who need to be able to actually make the game look good, and maybe the tech artists as well, they're going to come in and feed data into that ready-made shader, right? They don't have to know anything about the shader. They just know that it takes these inputs. And inputs could be anything really that define what that material, what that surface kind of should be like. Right? So that could be anything from like the color, could be like a texture, which kind of defines the surface, could be like other surface properties, such as how rough or smooth is it, right? Is it a metal? Is it a plastic? We're kind of getting into PBR here as well. Could be a normal map, right? Which just defines extra detail so that when we do our lighting calculations, it looks like it's a lot more detailed than it is. We have a lot of different things that we can actually do. There's other things that are used as well, like light direction, camera direction, all of that stuff that's required to be input into the shader. Although that kind of stuff is usually handled by the renderer and not by the material. But you kind of get my point. There's a lot of stuff that we kind of feed in. And obviously it could be fed in somewhat through the vertex attributes. That's kind of what we've been doing in a way. Like for example, we use the position of this triangle, I think, to actually work out its color, right? Yeah, because we have our varying color, and that is, oh no, that's our a color. I think at some point, I think for the triangle, we were just calculating the color to be like positions or something like that. That's done by just, taking in the vertex attribute for the position and then actually calculating, which fragment lies where, interpolating, and we get all these colors. That's fine and all, and we could obviously have a vertex color, right? But that obviously is, again, something that's baked into data. What if I want to be able to change that kind of on the fly, right? And that's where we get the whole data, having a bunch of data and then having a shader. And that data is called a uniform, right? We have uniforms, which is basically pieces of data that we can transmit to the shader at like before we draw, and it's done kind of per draw, right? And then that way when we decide to actually draw something and it needs to actually find that data, you can just access the data from the uniform, and that's it. We can now say that it's going to be red, it's going to be blue. So that's what a material essentially is. It's a shader which defines how everything, it's the code that says this is kind of the algorithm I'm going to use, this is what's going to happen to determine that final color, but it needs inputs, and those inputs are called uniforms. And that's what a material is. It's a bunch of uniforms and a shader. Shader and data. That's all it is. And it's pretty much that way in every game engine that I've ever seen. It's always a shader and a bunch of uniforms. And we might take a look at a more technical overview of that, as I said, in an in-depth video. But essentially, I'm just trying to put into your heads that that's really all it is. Obviously, the complexity of these systems can be enormous, because even though we do want our shader to be flexible, as I said, we don't want it to be flexible to the point of being very slow and doing like a bunch of if checks to check, is this what we want? Because you can make an Uber shader essentially, which is like just every possible thing, right? You can have one shader for your whole game, and that's all of the possibilities, right? But that's pretty bad. Like you don't want that. And so what ends up happening in the real world is an intelligent like shader compiler that you've written will essentially go through the shader and determine what is actually needed, and then kind of grab all the different building blocks of the stuff that's needed, combine that into a shader, and then just create that as a shader. So instead of having one shader that can do 300 things, you end up having 300 shaders, even though you wrote one. So more on that later, because we're definitely going to add a system like that sometime in the future. It's very useful. But anyway, I don't want to sit here talking for hours. I definitely could, especially because my mind is a bit fried. But I want to get in and basically write something like this. But our goal is going to be to try and make some of these squares different colors. And we're going to do that by making a material and then kind of submitting that material alongside our geometry that we actually submit. And then usually what would happen is if you have like a mesh or a model class essentially, which contains all of your geometry that you actually render, that also usually has materials associated with it. Because obviously if you kind of look at a game engine, you kind of author your assets in a way that like you're never dealing with code to this level usually, unless you're like experimenting or playing around with stuff. Usually artists will kind of make a 3D model, and they obviously want to apply a material to it in some sort of tool. And so that model gets linked with that material, right? Because it would be very weird if you kind of like, yes, you can have materials separate to geometry, but usually that's not the case. I mean, think about it. You're building this room and you want to render it in your game engine. This is a wooden table, right? You make the geometry for the wooden table, and then you apply the wooden material to it. You would never want to separate them, because that's just the way that this is, right? I mean, if you're building really dynamic stuff, the material might degrade or change over time. There are always exceptions, but the idea is that we want a mesh and we have a material with it. So usually those two pieces are tied together. So you wouldn't really just author a material right there and then in code. Definitely can do that. We definitely will support that. But I'm just trying to show you kind of the bigger picture of it. If I was actually building a game with Hazel or with an engine, how would that work? Anyway, we're going to go in and just literally play around with this code a little bit. This is going to be kind of more of a freestyle video where I just kind of just discuss what I'm doing so much, and we're not really writing final code, but we're just like talking about concepts and playing around with them and implementing somewhat of a system. But essentially, if we just kind of think about what we need, so we need a material class or something which holds a shader, which again is our compiled kind of shader program, and then we need some way to define data for it. Now, again, this system ends up being really complicated usually because the data that we define, like what data we define. How do we set uniforms properly? What happens if the uniform doesn't exist? Do we need to like actually check the shader code first to see what uniforms even exist? So those are the only ones that we can set, right? And then we also need to accept pretty much any kind of data. And then how do we interface with like uniform buffers or like DirectX as constant buffers, right? Where instead of submitting uniforms one by one, we usually submit a constant buffer. We might have multiple constant buffers because one might be submitted by the renderer or one might be submitted by the material. Huge task as usual because game engines are quite complicated. And we'll tackle these things slowly, but I just like to introduce them by showing a simple example so that people who aren't as experienced with this won't find themselves in the deep end as often and will actually be able to make sense of this. So let's dive into the code and we'll just play around with it and see what we can do. Okay, so the important stuff, again, is just, again, if you get overwhelmed with stuff like this, think about what it actually is. As I've mentioned before, it is a bunch of code, which is our shaders, right? We have a vertex shader and a fragment shader. The moment we're storing that in a shader, in a Hazel shader object, which is fantastic. That's all we need. And then we have a bunch of data. So we're not actually using uniforms at all at the moment. Oh no, sorry, we are for our vertex shader for like, for our transform and for our view projection matrix, and that's all fine. But we've never actually used uniforms, I think, in the fragment shader. So first of all, let's just take a look at what our end goal is. I want to make these, let's just say I want to make, maybe I'll make two different types of squares. So you saw we had a grid of squares. That's great. I want one of them to be blue, one of them to be red, right? So what I'll do is, so maybe we should make half of them blue, half of them red, I'm not sure. But basically what I'll do is, the first thing I'll do is just find the red color. So we'll have the red color, which will just essentially be a color, right? Now let's take our blue color because I want to make the red color the same kind of shade. So we'll make red color and a blue color. And they'll be vec4s. Let's just do this quickly. And then this will be the blue color. That's the blue color, and then the red color will be just 0.8, 0.2, 0.3. Okay, so we've got two different colors. I want to make, we can just literally alternate this. So what I can do is I can say essentially that if I, mod 2 equals 0, right? So this is just basically, oh, sorry, it's not I, it's X. So where kind of, as we go through the rows, every second one will be equal to 0, right? So 0 will be 0, 1 will be not 0, 2 will be 0, etc. What I'm going to do for that is actually set this shader, this blue shader's uniform, which I don't think we have a uniform map for. We'll do upload uniform float for. We'll set this to be the red color, and then otherwise we'll set it to be the blue color, right? So we kind of have an alternating pattern now. Now, obviously this is not efficient at all because usually you would like to batch together your materials. So in other words, you would like to do as few of these as possible. So what I would actually do is render all of the red squares first, then all of the blue squares. Just want everyone to understand this is just a test and we're not talking about efficiency or the optimal way of doing things. But we basically do this and we end up with an alternating pattern of colors. So let's visit our shader class and make sure that we have the right function. So we'll have upload uniform float for. This really needs some work, by the way, this shader class. So maybe that's something that I'll do next because, yeah, I mean, there's a lot of stuff that needs to be done here. We'll have values, I guess. I'll copy this, come over here, paste this in here. We'll get the location as usual. I saw someone leave a comment about caching the location. Yes, that can be done. That's not a bad way of that's a quick, dirty way of just saving some performance. Usually you wouldn't, usually you'd calculate all locations ahead of time when compiling your shader anyway. So that's not something that we're really gonna, what is it? Float for uniform vec. What is the function? I can't believe I don't remember this. Oh, it's just 4v, 4fv. No, 4f. Okay, there we go. Doing this from memory, of course. And then we have the location, and then values x, y, z, and w. Yeah, usually you would basically just have a system that reads the shader, parses the shader, gets all the uniform values from that, and then actually like gets the locations of all of those uniforms just right there and then. And then you do that when compiling your shader. That's it, that's done, they're saved. Because the shader is never going to change, right? If it does change, then you obviously recompile it. And then that way you also get other bonus things from that, like validation, making sure the shaders actually exist, making like, since you're aware of the shaders and their types, you know how big your buffer needs to be so that you can store all of them in a buffer. And that kind of just goes down that road. So we'll end up doing that in the future. So I'll call this my u_color. That's going to be the name of this uniform. Okay. And I'll just make this inside the blue shader, right? So the blue shader is now going to be a flat color shader. And I will actually go as far as to rename it flat color, just so that there's no confusion as to what it actually is. And then blue shader as well. Okay. So how do we add a uniform? Simple. We just type in the word uniform, and then the type vec4, and then the name of the uniform, u_color. And now what I'm going to do is output color to be uColor. Pretty simple. Could have made this a vec3 and just kept the alpha constant as 1 as well. That's fine. But we'll do that. Maybe you guys can try the other way at home. Let's hit F5 and we should get some kind of difference in our squares now. Some of them, half of them essentially should be blue, half of them should be red. Okay, and there you go. So you can see half of them are red and half of them are blue. That's perfect. So we've basically introduced a material, haven't we? We've got a shader that is somewhat flexible. We can add any color we want. We can easily just add an ImGUI control to actually change the color. In fact, that might be something you guys can do for homework. Just add an ImGUI control so that you can actually play around with the color, and we can do that next time as well. But essentially what we end up with is a way to actually pick any color we want and set it into the shader and then render something, and it will be with that actual value, with that red value or with that blue value, which is pretty cool. That's all great, but we never want to do this like this way, essentially, right? Where we actually kind of take the shader and then we upload a uniform float forward to it. That's weird. Instead, what we want to do is define some sort of material, more or less in an API that probably looks like this, where we have kind of Hazel, and I can show you kind of what a like an end goal API might look like, because we're definitely not going to make that today. But if I make a material, essentially, usually I take a material, probably have some kind of material ref, because we'll introduce some kind of automated kind of reference and counting system in the future. But for now, since we're using kind of raw pointers or smart pointers or whatever, let's just pretend that this is a ref. I guess I will show you the kind of final way. Basically, we can just make a material where we take a shader in, so this flat color shader, right? And you make a material out of that, right? And then what this does is like typically what this would do is actually take that shader, get all of the information about what data that shader needs. So in other words, the uniforms, specifically the uniforms that are applicable to actual like materials, right? So for example, as I mentioned before, if we look at this shader and we decide what uniforms do I want, right? Yes, we could take all of the uniforms, which would be 3. It would be these 2 in the vertex shader and this one in the fragment shader. Not good though, because a view projection matrix, how is that part of a material? It's not at all. Neither is a transform matrix. So maybe we take all the ones in the fragment shader. In this case, it will work. But what if we have like, I don't know, a uniform vec3, light direction? That's a bit weird, isn't it? I mean, why is a light direction part of a material? I say this all the time, but when you're designing things, make sure they make sense, right? This bunny here, which I've basically committed to picking up for every episode in this series. This bunny here, what's the material of this? Does it have anything to do with where the light is coming from, which is right there, by the way? No, it doesn't. It's just, yeah, sure, the light hits it, it reacts a particular way to the light. Why? Because it's got a material, right? It's got some kind of form, it's got a surface property that defines, like, it's all like kind of furry here and actually feels quite nice. But anyway, it has all of that. It's got a material, but it doesn't care where the light's coming from. That's not part of the material, right? I can't, like, changing the light direction does not change the material that this bunny is made out of, does it? Right? So just make sure that you kind of think things through in your head. Use a whiteboard or a piece of paper if you need to. Jot everything down. Ask yourself or ask someone else, does this make sense to you? Should the material for the bunny contain the light direction? The answer is no. So because of that, it's, again, you can't just take all the uniforms and be like, that's it, that's what belongs there. No, you need some kind of way to decide which uniforms should be set by maybe the renderer. So like the renderer should set the light direction, should set the view projection, and should set the transform. Transform's kind of per object, even though view projection is per scene, and so is light direction. But we also have another group of uniforms, which is to do with specifically the material. So we need to take those uniforms, and we need to basically create enough storage, like some kind of backing buffer that actually stores all the data that we need. And that's typically what would happen upon constructing a material. Once we have that storage, we'll be able to do things like material, material, maybe just set, and what are we setting? We want to set the color of the material, right? To be, red color. And that's it. Now, there's also the concept of materials and material instances, which are material instances are essentially just an instance of the material, because you might want to define a base material. For example, this, you know what I mean? Like, instead of making a red color, because this now becomes a red color material, doesn't it? I mean, it's like I've set the material's color to red, right? And then maybe I'll apply it to my mesh. So I had like a square mesh. Let's just say I had like a square mesh, right? And then I kind of just say, set material, or whatever, to, let's just say material, right? Or maybe I have an override material I can supply to the renderer, which says that even though the mesh might have a material, I want you to override it and set this material. That's useful for like debugging and also other kind of rendering cases. But anyway, what I've done here is I've created a red material. Great, that doesn't really solve anything. So what I might do is have just a flat color material, which is this, and then from there I might create something called a material instance, which is derived from this material, but has a specific set of data, right? That is unique per object or something like that. So another example might be I have a kind of physically based rendering metal material that's like silver, right? That might be my base material, but different spheres that I render might have different roughnesses, or they might be a bit damaged. So they might have a different like roughness or like specularity kind of like map, essentially like a texture that you apply that determines certain parts of the sphere look a bit beaten up, right? That would be like a material instance, because the base material is silver. It's like that kind of, the silver PBR material that you've created, but then the derived one might have a few kind of particular things that makes it unique, because obviously you wouldn't often render a scene filled with everything that is exactly in the same shape. It might be the same material, it might be a lot of wood in your scene, right? But it's likely that it's different types of wood, or it's different like qualities, like it might be a bit degraded or whatever. So we kind of end up with an API that somewhat looks like this. And this is something that I've actually done in the private branch that's available to patrons. By the way, huge thank you to all the patrons who make this series possible. Patreon.com/the Cherno. This stuff has already been done there. So I've kind of tested this code, and if you want to see it right now, you can just help support the series and you'll get access to all of this lovely code. But anyway, back to this. So I kind of have done this already, but essentially you might have like a material instance ref, which would be like your actual, material instance. This would just be, the same kind of thing where we have a Hazel material instance is made from a material. And then we can set certain like colors to that specific material, right? But that's kind of it. And then you end up with rendering something with a particular material instance. And in this example, you don't need to upload uniform float 4 or whatever, because you've already done that. we would instead, if I just kind of get rid of this code for now, we would instead go ahead and maybe submit something. We wouldn't use a shader anymore. We'd submit something with a particular material. And then what that material would do is upon us binding that material inside renderer submit, it wouldn't, like, the renderer does this stuff, that's fine. But ultimately we bind the shader and that's fine. That's all needed. That's all necessary. But then the next step for us would be to actually take that material instance and bind it. And by doing that, what that does is it binds the shader and sets all of the values that, sets all of the data that we've actually are storing inside material instance. And that's just fantastic, that whole kind of system. It's great. You can really extend it. You can make it really powerful. I might even wasn't planning on doing this, but I could show maybe next time this stuff kind of working. I'm not sure. Sometimes I'm not sure what the best way to explain some of these things are. And I definitely want to kind of do this in more of like a formal way with drawing diagrams and stuff. I think that's kind of important. But as we get into more complex topics in the engine, sometimes it's good to have an example. And I've tried to kind of do that for you with somewhat pseudocode, but also code that looks very similar to the final API that we're kind of working towards. But ultimately, you have kind of different, so I might show you some of the development branch stuff because, material instances, materials, all that stuff have been kind of vital to get that to work properly. And quickly as well, because again, once you have a bunch of objects that you render with different materials, you end up kind of being able to batch them together, so that you kind of do some render sorting essentially, so that you get all of the red squares, as I said here, and then all of why? Because the red squares have the red material instance. So let's, when we submit everything to the renderer, since we don't render everything at once, hypothetically in a good renderer, we have all that data, and then when it comes time to sort it, we can say, okay, well, everything that's red will render first, everything that's blue will render second. That way we only bind two materials, right? We bind the red material, render everything with it, bind the blue material, render everything with it. Obviously, certain shader properties like the transform still needs to be set, that's fine, but at least we're not setting the color every time we want to render one of these squares, because we are rendering 400 squares. If we do 400 material flips, that's going to take way longer than doing less. Anyway, I think that's probably about it in terms of what I wanted to show you guys. If we just jump back here for a sec though, textures work the same way, right? I mean, you could make a set texture. You don't necessarily have to. We haven't dealt with textures yet. That's something that we really need to do. But if we had a texture or something like that, we might have texture, we might have an albedo map or something. We can just set that basically by just uploading a texture reference or something like that in kind of the same way. Or you could be a bit more explicit so that you know what you're actually doing and do set texture, and maybe you have set texture, set value. You can design this API however you like, but essentially it works the same way for textures. And the material or the material instance would store a whole bunch of references essentially to textures. And then we could basically render something with a particular texture. So it's a really nice system. I really like the whole the concept of material systems. I've always kind of liked it because it's amazing how much safety it actually gives you. It's almost like smart pointers in a way. You could just upload uniforms, you look at kind of people learning OpenGL for the first time or graphics programming for the first time, what are they doing? Usually they create a shader. They'll be probably smart enough to create a shader class or something like that, and then an API that lets them set variables and set uniforms. And they can make something essentially that ends up, validating that, making sure stuff exists. Maybe if location equals -1, which means the uniform couldn't be found, they log that or they assert there so they can debug it. That's all great. But having a material system where you can actually, a proper one, where you can ask the shader, hey, give me all of your uniforms. Okay, it occupies this much space. Okay, I can store them in a buffer and then upload them when needed. Or I can have a material instance which overrides that buffer and says, this and that or whatever. It's just amazing because nothing will ever kind of go wrong with this if you write it properly. And that's kind of what we're going to do, obviously. So yeah, super excited for that. We need to, before we can actually do this though, we really do need to build up our shader class a little bit more. I mean, we can't even read shaders from files at the moment. So that's kind of definitely something that I want to do. The other huge question that I have for you guys, and I have asked that, but I'm going to ask it formally right now, so listen up. Do we want to proceed with making Hazel a full 3D renderer right now, or do we want to focus more on 2D? Again, materials less so useful for 2D because usually you would render pretty much everything in a 2D scene aside from like special effects or special things with just a single shader. So you don't really need too many materials. You can just have a 2D renderer which basically renders colors or textures and shapes. That's all you need. So it would kind of put this stuff on the back burner, which is fine. Either way, we still need to revisit our shader class, and we still need to 100% revisit textures. So I'll probably do one of those episodes next. But the real question is, and I'm going to make a poll. Last time I made a poll, I didn't really like it too much because I don't know how to see the results properly. The way I saw the results on my own poll last time was I watched the video myself, voted for something, then saw what the percentages were. I don't know how many people voted. I don't know anything about it. I should probably Google more maybe, but it just seems weird. I couldn't even see it in my analytics, so it's a bit weird. But I'll make a poll once again. Do you guys should we go in a 2D direction and make a cool, like blazing fast 2D renderer and just make Hazel able to make 2D games basically right now and just polish that up, make it ready to go? Or should we take a lot longer and make a 3D renderer? Either way, we're going to do 2D and then move on to 3D. The content will be there either way. Obviously, I'm very passionate about 3D. And I want to actually make a very good 3D renderer and a good 3D game engine. So either way, it's going to support both. There's no way I neglect it. Might make more sense to do 2D first, just so that it's finished, and you guys can actually start making games with Hazel and seeing it actually work as a game engine. I think that would be very cool. And obviously it's going to take a lot less time than a proper 3D renderer, so it might make more sense to do that. But either way, and I am going to continue the OpenGL series, by the way, so you'll see 3D stuff there. So if you're worried about just this channel being not 3D at all now for the next 6 months, don't worry about that, because definitely we'll be continuing 3D stuff in the OpenGL series for sure, either way. But if you want that, if you want 2D or 3D, let me know, vote in the poll, and I'll check the results next time and probably determine where we're going. But either way, we're doing the shader, so don't worry about that. Anyway, I hope you guys enjoyed this video. If you did, please hit the like button. As I mentioned earlier, patreon.com/thecherno is the best place to help support this series. Thank you to all of you people who make this series possible. I will see you next time. Goodbye.